In this lecture we'll answer two questions. On both questions we will find out the area of a trapezoid. So what is the trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. Side AB is parallel to the opposite side DC. The two parallel sides are defined as the bases of the trapezoid. Again, a trapezoid is a quadrilateral with one pair of parallel sides. And the area of a trapezoid is equal to the sum of its two parallel bases, that is to say it is AB plus DC times the height edge over 2. The height edge must create 90 degrees with the two parallel bases. Okay, so the area of trapezoid is equal to the sum of its two parallel bases. In this case it is A plus B times the height edge over 2. So in the first question, we find out the area of this trapezoid ABCD. It is given us in the question that the perimeter of this trapezoid is equal to 16 units. What is the perimeter? The perimeter is the sum of the lengths of all the sides of a trapezoid. Okay? That is to say, it is AB plus AD plus DC plus CB, and we know that sum is equal to 16. In addition, we know that side AB equals to 2 units in its length, and we also know that DC equals to CB in its length. Again, our mission is to find out the area of this trapezoid ABCD. In addition, we know that those two angles are right angles. Okay, we know that the perimeter of this trapezoid is equal to 16. That is to say, the sum of the lengths of all the sides of this trapezoid is equal to 16. It means that AB plus AD plus DC plus CB total is equal to 16 units according to what is given in the question. And again, according to what is given in the question, AB plus AD plus DC plus CB equals to 16. We define the length of side AD as A, and we define the length of this side DC as B. We know that DC equals to BC according to what is given in the question. So if DC is B, then BC must be also equal to B because they are equal to each other in their lengths. So AB is A, so we substitute AB by A. Actually AB is 2. So we substitute AB by 2 plus AD. AD is A, so we substitute AD by A. Plus DC. DC is B according to our definition, so we substitute DC by B, plus CB. CB is also B, and in total it equals to 16. So we found out that 2 plus A plus B plus B equals to 16. Here we subtract 2 from this equation, and we get that A plus B is plus 2B equals to 16 minus 2 is 14. So A plus 2B equals to 14. Here we subtract 2B from this equation, and we get that A equals to 14 minus 2B. So we found out that the length of side AD is equal to A according to our definition is equal to 14 minus 2B units. In the next step, we will do a construction, that is to say, from this vertex B of this trapezoid ABCD, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. By doing this construction, we can do quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. Those two angles are right angles according to what is given us in the question, and this is the right angle according to our construction. So we have 3 right angles inside quadrilateral ABDM. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4-facing angle, in total it must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this 4-facing angle must be equal to 90 degrees in its size. So inside this quadrilateral ABMD we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral ABMD as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB must be equal to the opposite side DM. But AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD equals to 8 is equals to 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B in its length. What is the length of this missing 978 MC? From the drawing it is very easy to see that MC equals to DC minus DM. Again, MC equals to DC minus DM. So I write it down. MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition. Minus DM. We just write down found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2 units. In the next step, I'll copy this right triangle BMC in a new pad and we'll implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Side BM equals to 14 minus 2 units. The hypotenuse BC equals to B and MC equals to B minus 2. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle BMC that is according to the original drawing. In this right triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equals to BM squared. BM is 14 rows to B, therefore BM squared is 14 rows to B squared. Plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. Here we open the brackets on this side of this equation and we get that B squared equals to 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared. Minus 2 times 14 times 2b, minus 2 times 14 is minus 20b, minus 28, and minus 2 times 14 is minus 28, and minus 28 times 2b is minus 56b. And we also plus b minus 2 squared. B minus 2 squared equals to b squared plus 2 squared, that is 4, minus 2 times b times 2, that is minus 4b. So here we have b squared on both sides of this equation, so b squared get cancelled, after cancelled b squared. In this side of the equation we left with nothing, that is to say 0, while in the other side of this equation we have 196 plus 4 is 200, and we also have minus 56b minus 4b is minus 60b, and also plus 4b squared. So here we divide this equation by 4. And we get that 4b squared over 4 is b squared. And we also minus 60b over 4 is minus 15b. And we have 200 over 4 is 50. And it is equals to 0 over 4 is 0. So in total we found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b. So x equals to b the coefficient A equals to 1, the coefficient B equals to minus 15, and finally the coefficient C equals to 50. So actually the only thing that is left to do is to put this data for one specific quadratic equation inside this general formula for x, and we find out the value of the values of b, because x equals to b. So we'll do it now and get that again x equals to b, therefore we substitute x by b, and it is equals to minus b. Actually the small letter b is the variable that we are looking for, and the big letter, the capital letter b, is the coefficient b of the quadratic equation, this quadratic equation. Okay, so b equals to minus b. The coefficient b equals to minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4, times c. C is 50, so minus 4 times 50 is minus 200. So inside the brackets we are left only with 225 minus 200 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total, if you found out that b equals to 15 plus minus, inside the root we have 225 minus 225, and the square root of 25 is 5, divided by 2. So here we will have two solutions that are possible for b. We define the first solution as b1 and the second solution as b2. So the first solution, b1, is b1 equals to 15 plus 5 over 2. And again, the first solution for b, this is b1 is equal to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So if you found out that b1 equals to 10, b1 equals to 10. So the first solution for b is b equals to 10, and we have also the second solution for b. The second solution for b is b2, and b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is equals to 5. So we have two solutions for b. The first solution is b1, that is equals to 10, and the second solution is b2, that is equals to 5. AD is one side of trapezoid ABCD, therefore it is a length, therefore it must be a positive number. And the length of AD is A, and A equals to 14 minus 2B. So A is a length, it must be a positive number. AD equals to A, that equals to 14 minus 2B. Again, AD is a length, and therefore it must be a positive number, that is to say it must be greater than 0. So 14 minus 2b, that is the expression for the length of A, it must be greater than 0. 14 minus 2b must be greater than 0. So we will add 2b to this inequality, and we get that 14 is greater than 2b. Here we will divide this inequality by 2, and we get that 14 over 2 is 7, and 7 is greater than 2b over 2 is b. So in total we found out that b is less than 7 units. B must be less than 7 units. But according to the first solution for b, that is b1, b is greater than 7 units. B equals to 10. But b must be less than 7 units. So the first solution for b, b1 that is equal to 10, is the correct solution. We can set the solution, and we left only with the second solution that is possible for b. This is actually b2, that is instead of b2, I don't that b equals to 5, because b is the only solution that is possible. B is equals to 5 is the only solution that is possible for b. So b equals to 5 units, and that is the only solution that is possible for b. So 5 is less than 7. So we found out that b equals to 5. So here we have b minus 2 is 5 minus 2, that is 3. So in total this equals to 2 plus 3, that is 5. Actually this is defined as b, so I trivial that b equals to 5, that this is equals to b equals to 5. So sin dc equals to b, that is 5. AB is 2 according to what is given as the question, and AD, that is A, is equal to 14 minus 2b. B is 5, so minus 2 times 5 is minus 10, and 14 minus 10 is 4. So AD equals to 4 units in its length. AD equals to 4. Our mission to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases. In this case it is AB plus DC, times the height over 2. AD is the height of this trapezoid ABCD. Why AD is the height? Because AD creates 90 degrees with the two parallel bases. Therefore AD is the height. So the sum of the two parallel bases, that is AB plus DC, times AD, that is the height, over 2 is the area of trapezoid ABCD. Hit again. The area of trapezoid ABCD is equal to AB plus DC, that is the sum of its two parallel bases, times the height AD over 2. AB equals to 2 according to what is given as the question. Plus DC, this is actually B, and B equals to 5. So this is 5. And AD is 4. AD is 4. The height AD is 4 divided by 2. So in total, we have found out that the area of trapezoid ABCD is equal to 2 plus 5, that is 7. And we have 4 over 2 is 2. So it is 7 times 2. 7 times 2 is 14. So we have found out that the area of trapezoid ABCD, that is the area that we are looking for in this question, is equal to 14 square units. That is the answer to the first question. And then again, if we found out that there, this trapezoid ABCD is equal to 14 square units. So finish with the first question. The next step, I present to you the second question, and we'll solve the second question of this lecture. In the second question, our mission is to find out the area of another trapezoid with the same name. It is also trapezoid ABCD, but it is a different trapezoid. So we have to find out the area of this new trapezoid ABCD. So, in the drawing, we have the new trapezoid ABCD, and on that side AD equals to 2x units in its length, side BC equals to x units in its length, according to what is given as the question. Line segment AM equals to 3 units, and line segment BM also BM equals to 2 units. Those angles are right angles, and this is also a right angle. Angle A and B is a right angle. Again, our mission is to find out the angle of this trapezoid ABCD. So first of all, we define this angle, that is actually angle BMC, is alpha. So in this right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line, DC is point M here. So here the sum of the angles must be equal to 180 degrees, according to rule 3, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this angle that is equal to 90 degrees, and this missing angle. So the sum of those three angles in total must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M, exactly according to rule 3. In this right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So, in those two right angles, in both those two right angles, we have angle alpha. In both those two right angles, we have angle that is equal to 90 degrees also, alpha. And in both those two right angles, we have this right angle. So those two right angles are similar to each other according to angle similarity rules. So I write it down. We should find out that the right big triangle ADC is similar. This is the sign of similar to the right small triangle BCM. According to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AD of the big right angle ADM over side MC of the small right angle BCM is equal to side DM of the big right angle ADM over side BC of the right small triangle BCM. Okay, again, from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. That side AD of the big right angle ADC or side MC of the small right angle BCM is equal to side DM of the big right angle ADC over side BC of the right small triangle BCM. And also side AM of the big right triangle AMD is equal also to side AM of the big right triangle ADM over side BM of the right small triangle BCM. So repeat again, if we found out that from the fact that those two right angles are similar to each other, the following relationship exists between their sides. That AD over MC equals to DM over BC equals to AM over BM. AD equals to 2x over MC. MC is the recent side, so we leave it as it is. And it is equals to DM. DM is the recent side, so we leave it as it is. Over BC. BC is x. And it is also equals to AM, that is 3 according to what is given as the question, over BM. BM is 2 also according to what is given as the question. So in total, we found out that two x over MC equals to DM over x equals to 3/2. Those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. That is to say, according to equation 1, 2x over MC equals to 3/2. So I write it down. So according to equation 1, 2x over MC equals to 3/2. So here we will multiply this equation by MC, and we get that 2x equals to 3 times MC over 2. So here we will multiply this equation by 2 and then we divide it by 3 simultaneously, and we get that MC, according to equation 1, MC equals to 2 times 2x, that is 4x, over 3. And again we have found out that MC equals to 4x over 3. So we have found out that this is line segment MC or side MC, that is equals to 4x over 3 units in its length. Those two expressions are also equal to each other, therefore we get equation 2 from those two expressions that are equal to each other, so according to equation 2, dm over x equals to 3 halves. Dm over x equals to 3 halves. So here we will multiply this equation by x, and finally we get that according to equation 2, dm equals to 3 halves times x. So dm equals to 3x over 2 units in its length. So I write it down. Here we have this is side dm that is equals to 3x over 2 units in its length. In the next step, I'll copy this right small triangle BMC in a new page, and we will implement the Pythagoras theorem on this right small triangle BMC. The hypotenuse BM equals to 2 units in its length, according to what is given as the question. BC equals to x units, according to what is given as the question also. And we just right now found out that side MC of the small triangle BMC is equal to 4x over 3 units in its length. Here by PT is a abbreviation for Pythagoras theorem. So actually, this is the right small triangle BMC and I copied from the original drawing. And again, this is the right small triangle BMC that I copied from the original drawing. In this right triangle BMC, according to the Pythagoras theorem, BM squared, that is the square of the hypotenuse, equals to BC squared plus CM squared. So I write it down. So BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equal to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we have found out that four equals to x squared plus 4x over 3 squared. 4x over 3 squared is 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total 4x over 3 squared is 16x squared over 9. So here we will multiply x squared by 9 and then we will divide it by 9 in order to have a common factor of this expression, and we get that 4 equals to 9x squared over 9. And we also plus 16x squared over 9. Nine x squared plus 16x squared is 25x squared over 9. So in total we should find out that 4 equals to 25x squared over 9. So here we multiply this equation by 9 and we get that 9 times 4 is 36, and 36 equals to 25x squared. Here we divide this equation by 25 and we get that x squared equals to 36 over 25. So here we take a root out of this equation and finally we get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total we should find out that x equals to 6/5 units in its length. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you at the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AD plus BC, times the height over 2. The height is DC. Why the height is DC? Because of the fact that the height DC gets 90 degrees with the base AD, this again equals to 90 degrees, and the height DC also creates 90 degrees with the other base BC. This again equals to 90 degrees. So this is the height divided by 2. So I put again, the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AD plus BC, times the height, that is DC, over 2. AD is 2x plus BC, BC is x, times DC. DC in total equals to 3x over 2 plus 4x over 3 divided by 2. So I put again, I should find out the area of this trapezoid ABCD is equals to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. Two x plus x is 3x. And we have here, inside the brackets, 3x over 2 plus 4x over 3. So we will multiply both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is 9x. And we have, well, 2 times 3 is 6. Likewise, we multiply both the numerator and the denominator of this expression by 2. 4x times 2 is 8x, so it is plus 8x. And the denominator will be 3 times 2, that is 6. So in total, we should find out that the area of trapezoid ABCD equals to 3x times 9x plus 8x over 6. we have to divide everything by 2. So we have to divide it by 2. So in total, if you found out the area of trapezoid ABCD equals to 3x times 9x plus 8x over 2 times 6. So the area of trapezoid ABCD equals to 3x. Inside the brackets we have 9x plus 8x, that is 17x, divided by 2 times 6. So here we will divide both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is x. So in total in the numerator we have x times 17x over, here in the denominator 2 times 6, and 6 over 3 is 2. So in total in the denominator we have 2 times 2. So 2 times 2 is 4, so in the denominator we have 4, while in the numerator we have 17 times x times x. We have already found out that x equals to 6/5. Therefore, we substitute x by 6/5 in this expression, and you get that the area of trapezoid ABCD equals to 17 over 4 times x, and x is 6/5, and we have x again, so it is 6/5 again. So in total, the area of trapezoid ABCD equals to this expression. 6 times 6 is 36, and 36 over 4 is 9. So we can set these 3 numbers, and instead of those 3 numbers, we write down 9, because 36 over 4 is 9. So we have 17 times 9 over 5 times 5 is 25. 17 times 9 is 153 divided by 25. In terms of numbers, it is equals to 6.12 square units. So we found out that the area of this trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. And that is the answer to the second question. In the next step, as soon as the lecture, we start with the first question, of course. It is again the area of trapezoid ABCD equals to either 153 over 25 square units, or in terms of numbers, it is equals to 6.12 square units. So what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. Side AB is parallel to the opposite side DC. If we define the length of AB as B and the length of DC as A, then the area of this trapezoid ABCD will be equal to A plus B, that is the sum of its two parallel bases, times the height edge over 2. So the area of a trapezoid is equal to the sum of its two parallel bases times the height edge over 2. This is A plus B times edge over 2. The height edge must create 90 degrees with the two parallel bases. This height edge creates 90 degrees with the base AB, and edge also creates 90 degrees with the other base DC. What's it equals to 90 degrees. Okay, so the area of trapezoid the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. In the first question, our mission is to find out the area of this trapezoid ABCD. It is given us the question that the perimeter of this trapezoid ABCD is equal to 16 units. What is the perimeter? The perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. In this case, the perimeter of this trapezoid ABCD equals to AB plus AD plus DC plus CB. That is the sum of the lengths of all the sides of this trapezoid ABCD. And we know that it is equal to 16. So AB plus AD plus DC plus CB in total is equal to 16, according to what is given as a question, because the perimeter of this trapezoid ABCD is 16 units. And again, AB plus AD plus DC plus CB equals to 16. AB is 2. We define AD as A and BC as B. Because of the fact that DC equals to CB according to what is given as a question, so if DC is B, then CB must be also equal to B because they are equal to each other. So in total, the perimeter of this trapezoid ABCD equals to AB, that is 2, plus AD, that is A, DC is B, CB is B, and it is equals to 16. So 2 plus A plus B plus B equals to 16. Here subtract 2 from this equation. So 16 minus 2 is 14. And then in this side of the equation we have A plus B, that is A plus 2B, and it is equals to 14. Here we subtract 2B from this equation, and finally found out that A equals to 14 minus 2B. So actually, AD equals to A, and A equals to 14 minus 2B. Okay, so in the next step we did a construction, that is to say, from this vertex B of this trapezoid ABCD we drew perpendicular on DC. Again, from the vertex B of this trapezoid ABCD we drew perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we can do quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 pieces again, in total they must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, these 4 pieces again must be equal to 90 degrees in its size. So inside quadrilateral ABMD we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a right angle if not a square. So we learn to this quadrilateral ABMD is right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So right angle ABMD, side AB must be equal to the opposite side DM, but AB is 2, therefore the opposite side DM must be also equal to 2 units in itself. Likewise, according to the sum rule, in the sum of angle ABMD, side AD must be equal to the opposite side BM, but AD equals to 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. What is the length of this miscellaneous segment MC? MC equals to DC minus DM. Okay, MC equals to DC minus DM. So MC equals to DC, that is B according to our definition, minus DM. We just write down that the DM equals to 2. So in total, MC equals to B minus 2 units in its length. In the next step, I complete this nice triangle BMC in a new page and implemented the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle BMC that I copied from the original drawing. In this right triangle BMC, BC square, that is the square of the hypotenuse, equals to BM square plus MC square. BC is B, therefore BC square is B square, and it is equals to BM square. BM is 14 minus 2B, therefore BM square is 14 minus 2B square, plus MC square. MC is B minus 2, therefore MC square is B minus 2 square. So in total, if we found out that b squared equals to 14 minus 2b squared plus b minus 2 squared. We open the brackets on this side of this equation, and if I found out that b squared equals to 14 minus 2b squared. 14 minus 2b squared equals to 14 squared, that is 196, plus 2b squared. 2b squared is 4b squared, plus b minus 2 squared. b minus 2 squared equals to b squared, plus 2 squared, that is 4, minus 2 times b times 2, that is minus 4b. So here we have b squared on both sides of this equation, so b squared will get cancelled. After cancelled b squared in this side of the equation, we left with nothing, that is to say 0. While on the other side, on this side, on the other side of the equation, we left with 196 plus 4, that is 200, and we have also minus 56b minus 4b, that is minus 60b, plus 4b squared. So in total, if we found out that 0 equals to 200 minus 60b plus 4b squared. We divided this equation by 4, and if I found out that 4b squared over 4 is b squared, minus 60b over 4 is minus 15b, and 200 over 4 is 50. So in total, if you found out that b squared equals to 15, b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus 4 to b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0. The variable that we are looking for is b. Therefore, x equals to b. The coefficient a equals to 1. The coefficient b equals to minus 15. And the coefficient c equals to 50. The only thing that is left to do is to put this data from our specific quadratic equation, this quadratic equation inside this general formula for x. And in this way, we found out the values of b, because x equals to b. So if we did it, so x equals to b, so substitute x by b, and if I found out that x equals to minus b is 15, therefore b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus 4 to b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is 50, so minus 4 times 50 is minus 200. So in total, inside the brackets we have 200, inside the root we have 225 minus 200 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total, if you found out that b equals to 15 plus minus 225 minus 200 is 25, and the square root of 25 is 5. Divided by 2. So b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. We define the first solution as b1 and the second solution as b2. So the first solution, b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b, that is b1, is equal to 10 units. The second solution for b is b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b, b2 is 5, and the first solution for b, b1 is 10. You know that AD is one side of trapezoid ABCD. Actually, it is the length of one side of trapezoid ABCD. So AD is a length, it must be a positive number. AD equals to A according to our definition, and we already found out that A equals to 14 plus 2B. And AD is a length, it must be a positive number, that is to say, it must be greater than 0. So this expression that represents the length of A must be a positive number. What is a positive number? It must be greater than 0. So 14 plus 2b must be greater than 0. We added 2b to this inequality. we found out that 14 is greater than 2b. Then we divided this inequality by 2 and we found out that 14 over 2 is 7, and so 7 is greater than 2b over 2 is b. So we actually found out that b is less than 7 units from one side, but from the other side we only found out that b1 equals to 10. 10 is greater than 7, but b must be less than 7. So this solution is a correct solution. We cancel this solution and we left only the second solution that is possible for b. b2 is 5, or b is 5. So we found out that b equals to 5 units in its length. That is to say, DC that is equals to b according to our definition is equal to 5 units. AB is 2 according to what is given as the question. AD equals to A according to our definition, and A equals to 14 minus 2B. B is 5, so minus 2B is minus times 5, that is minus 10. And 14 minus 10 is 4. So in total we should find out that AD equals to 4 units in its length. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you at the beginning of the lecture, the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC times the height AD divided by 2. And again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC times the height AD over 2. AB is 2, and DC is B and B is 5, so DC is 5, the height AD is 4, so AD is 4, divided by 2. So in total we found out that 2 plus 5 is 7, and 4 over 2 is 2. So in total this expression equals to 7 times 2, that is 14. So we found out that the area of this trapezoid ABCD is equal to 14 square units. So we finish with the first question. The next step I present to you the second question and solve the second question of this lecture. In the second question, our mission is to find out the area of another trapezoid with the same name. It is also trapezoid ABCD, but it is different trapezoid. It's given us the question that AD equals to 2x units in its length, BC equals to x units in its length. This is 97 AM, this equals to 3 units. This is 97 BM, this equals to 2 units. Those two angles, they are right angles. This is angle AMB, that is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define the size of this angle, BMC, as alpha. So in the right front angle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We have also rule 3 that said that the sum of the angles on one side of a straight line is equal to 180 degrees. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this angle that is equal to 90 degrees in its size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles of the upper side of DC at point M according to rule 3. So this missing angle must be equal to 90 degrees minus alpha. In the right angle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees. Therefore, this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So if you found out that those two right angles, that is to say the right big triangle ADM and this right small triangle BCM, they are similar to each other according to angle similar to rule. Why? In both triangles we have angle alpha, in both triangles we have this angle that is right angle, and in both triangles we have this angle that is 90 degrees belongs to alpha. Therefore, those two right angles are similar to each other according to angle similar to rule. So, okay, again. The right big triangle ADC is similar, this is the sum of similar to the right small triangle BCM according to angle similar to rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AD of the big right triangle ADM over side MC of the small right triangle BCM is equal to side DM of the big right triangle ADM over side BC of the small right triangle BCM, and it is also equal to AM of the big right triangle ADM over BM of the right small triangle BCM. And again, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so leave it as it is. DM is also the missing side, so leave it as it is. Over BC. BC is x. And it is equals to AM that is 3 over BM that is 2. So in total, we shall find out that 2x over MC equals to DM over x equals to 3 halves. Those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. According to equation 1, 2x over MC equals to 3 halves. 2x over MC equals to 3 halves. Again, 2x over MC equals to 3 halves. If you multiply this equation by MC, and finally found out that 2x equals to 3 halves times MC. Here we multiplied this equation by 2, and then we divide it by 3 simultaneously, and finally found out that MC equals to 2 times 2x is 4x over 3. Again, MC according to equation 1 equals to 4x over 3. MC equals to 4x over 3. Those two expressions are also equal to each other, therefore we get the equation 2 from those two expressions that are equal to each other. So according to equation 2, dm over x equals to 3 halves. Again, dm over x equals to 3 halves, according to equation 2. Here we multiply this equation by x, and finally found out that dm equals to 3 halves times x, so 3x over 2. Here dm equals to 3x over 2. In the next step, I go with this right small triangle BCM in a new page, and we implemented the Pythagoras theorem on this right small triangle BCM. So actually, this is the right small triangle BCM that I copied from the original drawing. This triangle BCM from the Pythagoras theorem, BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4. And it is equals to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we shall find out that 4 equals to x squared, and 4x over 3 squared is 16x squared over 9. So here we multiply the x squared by 9, and then we divide it by 9 in order to have a common factor with this expression. So we have 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared divided by 9. So in total, we found out that 4 equals to 25x squared over 9. Here we multiply this equation by 9, and finally found out that 25x squared equals to 4 times 9, that is 36. Here we divided this equation by 25, and finally found out that x squared equals to 36 over 25. Again, x squared equals to 36 over 25. Here we took out of this equation and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total x equals to 6 fifths. So x equals to 6 fifths. X it is actually the length of side BC of trapezoid ABCD. Again, our mission, actually side AD is 2x. Again, our mission is to find out this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases. In this case, AD is parallel to BC, so it is AD plus BC times the height, that is DC over 2. Why the height is DC? Because of the fact that the height DC creates 90 degrees with the two parallel bases. So in total, if you found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, that is AD plus BC, times the height DC over 2. Repeat again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is AD plus BC, times the height DC over 2. AD is 2x and BC is x. Repeat again, AD is 2x and BC is x, times DC. The height DC equals to, in total, 3x over 2 plus 4x over 3. So the height DC equals to 3x over 2 plus 4x over 3, all divided by 2. 2x plus x is 3x. Here we have 3x over 2 plus 4x over 3. Actually, we created here a common factor. Actually took out a common factor of 6 from those two expressions by multiplying this expression, both the numerator and the denominator of this expression, by 3. This way we got that 3x times 3 is 9x and 2 times 3 is 6. Likewise, we multiplied both the numerator and the denominator of this expression by 2. So 4x over 2 is 8x and 2 times 3 is 6. So in this way, we took out 6 as a common factor from those two expressions. We found out that 3x times 9x plus 8x over 6 over 2 is the area of trapezoid ABCD. So we have 3x, inside the brackets we have 9x plus 8x, that is 17x, over 2 times 6. So here we have, we divided both the numerator and the denominator of this expression by 3. 3x over 3 is x. So we left only if x times 17x in the numerator. In the denominator we have 6 times 2. So 6 over 3 is 2. So in the numerator we left only with 2 times 2. So we divided both the numerator and the denominator by 3. So in total, we have found out that the area of trapezoid ABCD equals to x times 17x over 2 times 2. 2 times 2 is 4. So in the denominator we have 4. While in the numerator we have 17 times x times x. We have already found out that x equals to 6 fifths. So we found out x in this expression by 6 fifths. So this expression equals to 17 over 4, and x is 6 fifths, and we have x again, that is 6 fifths. 6 times 6 is 36, and 36 over 4 is 9. So we cancel those three expressions, those three numbers, and instead of those three numbers, we add down 9, because 36 over 4 is 9. So in total, we left with 17 times 9 over 5 times 5, that is 25. 17 times 9 is 153. So in total, this expression equals to 153 over 25 square units. So in terms of numbers, it is 6.12 square units. Repeat again, we actually found out that the area of this trapezoid ABCD, that is the area that we are looking for in this question, it is equal to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.